you ever look at an app on your phone and just wonder, how in the world did they make that? Well, today, we're going to pull back that curtain. We're going to build a real, working Java application completely from scratch. And by the end of this, you'll get the fundamental logic that makes pretty much all software tick.
It really does seem like magic, doesn't it? You tap a button and all this logic just happens. But it's not magic. It's really just a set of instructions, kind of like a recipe. And today, we're going to write that recipe together. We are starting with a totally blank page, and we're ending with a program that you built. Okay, so before we can even think about writing our own code, we have to understand the blueprint. You know, every single Java program out there, from a tiny calculator to a massive corporate system, it all starts with the exact same structure. These are the ground rules, the unbreakable rules. And this is it. Don't let all the weird words scare you off. Just think of public class main as the blueprint for our entire house. And inside that public static void main part, that's the front door. It's the official starting line where Java says, okay, I'm starting right here. Everything we build, all our furniture, all our code, it has to live inside those curly braces. That's the one rule you just can't break. So here's the hierarchy that's always at play. Every little thing we want the program to do, we call that a statement. Those statements get grouped together into a set of instructions, which we call a method. And every single method has to live inside that main container, the class. It's that simple, really. The container holds the instructions, and the instructions hold the actions. All right, so our house has walls and a door. Now it's time to put some stuff in it. In programming, our stuff is data. You know, numbers, words, true or false answers. But before we can use any of that, we need a place to store it. So let's talk about the building blocks for that. And the most basic building block of all is something called a variable. Honestly, the absolute best way to think about it is just as a labeled box. You give the box a name, you put a piece of information inside, and then you can grab it and use it later. Simple as that. And here's what that actually looks like in the code. First, you declare that the box even exists. You're basically saying, hey Java, I need a box that can hold a whole number and I'm going to call it age. Then, in a second step, you assign a value to it. You're putting the number 25 inside that box. It's always two simple steps. Create the box, then fill the box. Now here's the thing. These boxes come in different shapes and sizes because they're built to hold different types of data. This is super important. We have to tell Java what kind of info to expect. An int is for your whole numbers. A double can handle decimals. A Boolean is super simple. It just holds true or false. And a char is for just one single character. And this isn't just for us. It tells the computer exactly how much memory it needs to set aside for each box. And all those data types basically fall into two big camps. First, you have primitive types, like the ones we just saw. These are like having cash right in your pocket. The value is right there, stored directly. But then you have reference types. These are a little different. They're more like having the address to a bank. They don't hold the money itself, just the location of where to find it. So let's just lock that in, okay? Primitives are the data. References are just the directions to the data. Now, for the app we're building today, we're going to keep it nice and simple and just stick with the primitives, the cash in our pocket. Okay, so quick recap. We have a house, and it's filled with our labeled boxes of data. So what now? Just having stuff isn't that useful, right? We need tools to actually do things with it. It's time to make something happen. And those tools are called operators. They're just special symbols that let us perform actions. Think of them as your calculator for doing math, or a magnifying glass for making comparisons. They're the verbs, the action words of programming. And the tools you'll probably reach for most often are these guys, the arithmetic operators. You recognize most of them: plus, minus, multiply, divide. That last one, the percent sign, might be new. It's called modulus, and it sounds way more complicated than it is. It just gives you the remainder after you divide two numbers. That's it. So let's put them to work. Take a look at this expression right here. We want to figure out what the result is. Seems pretty straightforward, right? Or is it? So take a second. What do you think? If you just go left to right, 10 plus 20 is 30, and 30 times 3 is 90. Okay, but what if you do the multiplication first? 20 times 3 is 60, and then 10 plus 60 is 70. So which one is it? Which one does Java pick? The answer is 70. And this is a perfect example of a really key concept, operator precedence. It's just like what you learned back in math class. Java has an order of operations. It knows it's supposed to do multiplication and division before it does any addition and subtraction. All right, this is it, the moment we've been building up to. We have the blueprint for the house, we have the boxes for our data, and we've got the tools to work with it. Let's head to the assembly line and put all these pieces together to build our first app. So here's the plan for our app. We'll call it the Student Marks Analyzer. It's got 3 very simple goals. First, get 3 scores from the user. Second, do a little math to calculate the total and the average. And third, display a nice, clean report back on the screen. First things first, we need to get the input from the person using the app. To do that, we use this handy built-in Java tool called a scanner, which is designed to, scan for keyboard input. That line, sc.int_parens, basically tells the program to just pause and wait for the user to type in a whole number. Once they do, we'll store that number in our variable m1. And then we just do that 2 more times for the other subjects. Okay, next up, the math. This is where our operators get to shine. We use the plus sign to add up our 3 marks, and we pop that result into our total variable. Then, to get the average, we divide by 3. But look really closely. We're using 3.0, not just 3. This is a little pro tip. By adding that decimal, we're signaling to Java, hey, the answer to this might have a decimal, so make sure you use a data type that can handle it. That's what ensures our accurate average. And finally, step 3, we show our work. That system.out.println command is basically just a fancy way of saying, hey computer, print a line of text to the screen. And what we're printing is a label, like total marks, followed by the actual number that's stored inside our total variable. And just like that, we've built an app. But what happens when it doesn't work? Because trust me, it's going to happen. So let's cover one final, absolutely crucial pro tip that every single programmer needs to know: the art of finding and fixing bugs. I really, really want you to remember this quote, because it's one of the biggest truths in all of programming. Writing the code is just part of the job. Debugging, that whole process of hunting down and fixing problems, it isn't a sign that you messed up. It is the work. The best developers out there aren't the ones who write perfect code on the first try. They're the ones who are masters at figuring out why things break. And there you have it, the blueprint, the data blocks, the tools. You've seen how they all come together to make a real application. You now have the absolute fundamental building blocks of programming. So the only question left is, what are you going to build first?